Hello everyone. In this video, we once again see how we can solve a second order differential equation in Python. Our example is d2y dt squared, because this is a function of t, so it is minus 3 dy dt minus 2y of t is equal to 0. This is a homogeneous second order differential equation, because f of t at the end of the day is equal to 0. So what do? We have to use SymPy of Python. So we have to import SymPy as sim. Now we also need to define this t as a symbolic variable. Remember, this is an independent variable, so we have to define it as a symbolic variable. How about y? Y is now a function of t, so that's why we need to define it differently as sim.function of y and being a function of t. Then we need to define our differential equation using the function sympy.eq. So this equation is going to be 1. We are saying this is a function y of t. So what we do, we have to write y dot diff t comma t, because we are saying this is the second derivative of y with respect to t. Then minus 3y, so which means we are going to say 3 times y, then dot diff of t. So this is diff of t, meaning it is the first derivative of y with respect to t, then plus 2 times y, then comma. What we put after a comma is the value that is on this side of the equal signs on the differential equation. So since on the other side it is a homogeneous equation and f of t is equal to 0, then we put 0, then we close the brackets. So we are going to use the function, maybe we can call this one, okay, we can leave it as a general solution is equal to sim.dsolve. We are using the function dsolve to solve this differential equation that we have just defined. So we are solving this differential equation, which is a function y being a function of t. This is how we use dsolve. This is when we don't have the initial conditions. Please, at the end of the day, we are producing a general solution that has constants in it. So that's in case you are provided with the initial conditions, then you could create them here as a dictionary of key values, whereby the key will be now the y of 0, then the value would be now the value of y of 0. Then you continue, since it's a second order differential equation, you'd also need dy dt. So dy dt of 0, or the value of dy dt at t is equal to 0, then its value would be the value provided. So you create that dictionary and be able to solve this differential equation without constants. But in this particular method, we are going to return constants. So let us now, first of all, print our differential equation. We are going to create a space in between our answers. So what we do this, print nothing, print nothing. Okay, so we are going to print our differential equation, first of all, this equation, then we also print our solution. So the y solution or the solution that is now a function of y, function y, which is a function of t, is going to be, we said this is general solution, dot RHS. So what we are going to produce, this d solve returns a particular function. So what it is going to do, it prints out to something, then also what is on the right hand side. Since we are interested on what is on the right hand side, we are going to say that general solution dot RHS to mean the right hand side. Okay, so what does that mean? We are going to run this and we see. So when we run, we have a differential equation which is 2 times y of t minus 3 times second derivative of y with respect to t plus the first derivative of y with respect to t, and which is actually this is 2 times y minus 3 times the first derivative of y plus the second derivative of y with respect to t. And the solution is exponential c1 exponential of t plus c2 exponential of t, everything squared. So SimPy has simplified this by creating a bracket outside of factorizing out the exponential of t. Let's go back to our code and we see. Now, sometimes after us writing this differential equation, we want to use any constants that we love. For Python, it is going to use C1 and C2, but if at all we want A and B, so what we do, we are going to look at how we can change C to A, then C1 to A, then C2 to B. So we are going to also say that that general solution dot RHS, that particular component on the right hand side, dot we substitute. So if we substitute, now we create a dictionary, the key and value. The dictionary always takes key and value. So when you look at the C1, that is a key and the value is A. So we are going to substitute C1 with A, then also C2 with B. If there was another constant created like C3, we could also maybe substitute it with another constant, for example, maybe C or K or any other. So what we do, we are also going to print, the general solution. We can maybe suppress this and run our code. So you can see our code prints the component on the right hand side. Let us maybe call this one. We can call this y1. Then we print also print nothing, then print nothing. And now finally let us print. Let this one will be y1, should be y1, and then let us also now print y solution, which is our final solution now. Let's run this and we see. So you can see the first solution we had C1 and C2. Those are default from Python, And now our final solution has A and B. In other words, C1 has been replaced with A and C2 replaced with B. So in simple terms, we have looked at in summary, we have looked at the general solution of a second order differential equation using the DSOLVE function and using the .eq function for us to write the differential equation, and also utilizing the dictionary as a data structure or data type. Actually, let me say data structure for us to be able to substitute the constants C1 with the A and C2 with the B. And we have produced the general solution of our second order differential equation. The general solution in this case retains or maintains the constants because we are not provided with the initial conditions. If the initial conditions were provided for, then we would produce the general solution that does not have constants. Thank you so much. See us in the next lecture.